So Thursday's page of the packet has 9 examples. I guess it's pages of the packet, has 9 examples. And in each example, we are going to start first by getting 0 on one side. We always have to have 0 on one side. That's how we solve. That's what solving means, is you set it equal to 0, and then you figure out what x is. But once we have 0 on one side, then we need to determine what form the quadratic is in. So it might be standard, it might be factored form, it might be vertex form, and we have to identify which. The form then helps us figure out what method we need to use to solve, and then we'll solve it. So let's do example 1 together. First, make sure that your equation is equal to 0. Our equation is equal to 0, we're good. We don't even have to do anything to make that happen. Now, let's identify what form the quadratic equation is in. And you might want to flip back to yesterday's page in the packet. At the very top, we have our 3 different forms here, and you can just kind of see what they look like. Factored form has 2 different factors being multiplied together. Standard form is just terms, ax squared plus bx plus c. And then vertex form is kind of a weird combination of both. The one thing I do want to point out is bx. See this right here? This is a number multiplied by an x. So it might be like a 5x, or it might be a negative 3x, or it might be just a 1x. Let's not do that. Maybe it'll be a negative x. The only form that we have with a number being multiplied to x is standard form. So if you ever see a bx term, you know you're in standard form. Vertex form and factored form will always have some kind of factor in them, and vertex form can have a number being added or subtracted on the end. So just a few little differences and similarities among these forms that we're going to have to keep in mind and look for as we're identifying them throughout today's examples. So go back down to Thursday's page. Take a closer look at this quadratic equation. Which of the forms does this resemble? Oh, I just realized we might not have been able to see the whole screen there. Which form does this most closely resemble? Ben? That's correct. This is vertex form. Vertex form usually is a x minus h squared plus k. So in this example, our a happens to be just a 1. There's no number in the front, so we could put a 1 there. Our h is 8, our k is negative 2. So you can almost see how the various pieces line up. So on the blank to the right, we're going to write vertex form. And if it's in vertex form, how do we solve it? This is also on yesterday's page in the packet. What does it say? Right under vertex form, to solve for x, we use inverse operations. Thank you. To solve vertex form, we use inverse operations. This is what we practiced yesterday. So let's actually solve now. Remember that inverse operations have to be done in a very specific order. It's PEMDAS backward. So we start with AS, then we do MD, then we do E, then we do P. PEMDAS backward. So first, we're going to undo the addition and the subtraction. So it's this negative 2, this minus 2 that we're going to undo first. We undo a minus 2 by using a plus 2 on both sides. So the minus 2 and the plus 2 will cancel each other out on the left. And now we have x minus 8 squared equals positive 2. The next step we do is undoing multiplication or division. Now, often we will have a number in front of these parentheses that's being multiplied to the parentheses, but there's no number here. So we don't actually have to worry about this step. There's nothing being multiplied, so we don't have anything we have to undo. So move down to the next step, which is undoing exponents. We do have an exponent that we have to undo. We're going to have to undo a square. And what's the inverse of a square? A square root. Thank you, Chrislyn. So we're going to take the square root of both sides. Something weird happens here. Does anybody remember what it is? We get a plus and a minus answer. You get both the positive and the negative. So on the left, the square root and the square cancel each other out. That was the whole point. We wanted to undo it. So we'll just have x minus 8 on the left now. And on the right, we have a plus or minus square root of 2. Which I know looks weird, but remember, this is just our two different answers. One of our answers is going to have a plus square root of 2, and our other answer will have a minus square root of 2. That's all this is. We do have one more step, though. The last step that we do is undoing whatever is in the parentheses. We do have an x minus 8 in the parentheses. We need to undo that minus 8. So we add 8 to both sides. So now on the left, we just have an x. And on the right, we're going to put the 8 in front. We have 8 plus or minus the square root of 2. And just so you know, it is okay to write your answer this way. You can leave your answer just like this. This is correct. It is also correct to write your answer as 8 plus the square root of 2 and 8 minus the square root of 2. So you can either leave it together as a plus and minus, or you can split it apart into two separate expressions. They're both right. The reason I wanted to show you both of these is because on a quiz, you're going to be dealing with a multiple choice question, and I'm not sure which way the quiz will present the answers to you. So you need to know that both of these forms are correct answers. I know, based on our conversations yesterday, that solving using inverse operations is already beginning to come naturally to you guys. I know that this process makes sense to you, and I have every amount of faith that you can do these problems correctly. The real trick to most of these problems is actually the very first step, identifying what form the quadratic is in. And I personally think that's the toughest part. So what we're going to do for the rest of class is I am going to set you loose. I am throwing you to the wolves, and you are going to have to fight your way through these problems. Trust me, they are not as easy as they look. In a lot of these, you will have to really think about whether it's vertex form or standard form. Factored form is usually pretty easy, but vertex form and standard form can look a lot alike. So pay close attention to these problems. If you get stuck, ask me questions. And I also encourage you to work with a partner. So maybe check your work with a neighbor. Ask the person sitting next to you, like, hey, what did you get for number 2? Is this vertex form or standard form? And talk about it. So help each other and get help from me too if you need it. So go ahead and try some of these on your own. I'll be around to check on you and answer your questions. And toward the end of class, we will actually go over most of these together as well too. So, okay. All right, so follow along as I go through each of these problems and check your own work against mine. If you made a mistake, correct your mistake on your own page so that you know later how to actually do these problems. In example 2, identify the form this is in. This to me looks like factored form. We have two factors being multiplied together. So the method we use to solve this is set each factor equal to 0. And if you didn't know that, you could just look back at Monday's page, at Wednesday's page of the packet, yesterday's page of the packet. So I say this all the time, I'm going to repeat myself again. If we have two factors that are multiplied together and it equals 0, one of the factors has to be 0. So either x minus 4 equals 0 or 4x plus 1 equals 0. We solve each of these for x and we get x equals 4 or x equals negative 1 over 4. These are our two answers, 4 or negative 1/4. Okay, most of these will have two answers. We often have two answers with our quadratic equations. Take a look at example 3. Example 3 tricked some people. Is this standard form or vertex form? It is vertex form. At first, it kind of looks like standard form, but the most important part of standard form, what makes it standard form, is the bx. I mentioned that at the beginning of class. If you don't have a middle term, it's way easier to classify this as something different. Standard form is hard. Standard form, we have to factor it, and that's usually pretty challenging. So if at all possible, we would much rather classify this as something else rather than standard form. This fits the vertex form model. It might look a little weird, but what if I did this? That looks a little bit more like vertex form, right? I just threw parentheses around the x, and you could pretend like there was a 1 here and an x plus 0. This is vertex form. It's just harder to see because it has some things missing, but this is vertex form. So put that on the line. Vertex form, which means we're going to solve it using, Cole, what do we solve using?
Inverse operation.
You got it. Inverse operations. So that's PEMDAS backward. AS, MD, E, P. First, we start by undoing addition or subtraction. All we have to do here is add 43 to both sides. Then we try to undo multiplication or division, but we don't have any of that. So we don't have to do that step. Next, we undo exponents. We do have an x squared. We'd like to get rid of that square. So we undo it by square rooting both sides. When we do that, we get that weird plus or minus thing showing up. So on the left-hand side, the square root and the square cancel, leaving us with just an x. And on the right, we have a plus or minus square root of 43. Does this simplify? Does 43 have a square root? No, it would be some kind of weird decimal number. So we're going to leave it just like this. This is our answer. We can write it in this form, or we can rewrite it as positive square root of 43 and negative square root of 43. Those are our two answers, but you are allowed to leave them together, or you can split them apart. Totally up to you. Let's move on. Example 4. What form is this in? This is standard. Because it has a 14x, that's our bx, that's our middle term, there is no way that we could call this vertex form. This is also definitely not factored form. This is standard form. In order to solve a standard form quadratic, we have to factor it. That's our method. So, unfortunately, we're going to have to set up a rectangle with a 5x squared and a negative 3. We've got to figure out two things that multiply together to give us 5x squared. So we're going to use 5x and x. And we need two things that multiply together to give us negative 3. So I'm going to use 1 times 3, but one of them will have to be a plus and the other will have to be a minus. We are going to be using a 1 and a 3 for sure, but it's our job to figure out where. And to do that, we have to pay close attention to what's in the middle. That bx term, the one that made this standard form to begin with, comes from here and here. So if I want that to be a 14, you better believe I'm going to put the 3 here. That'll give me a 15x, and a 1 here, that'll give me a 1x. So now with a 15x and a 1x, I can get a 14 out of those by using a difference. So we'll have a plus and a minus. Okay, rewrite this in factored form. X plus 3 times 5x minus 1 equals 0. And we now have to use the method we use for factored form. We have to set each of these equal to 0, solve each of them for x. We end up with two answers, x equals -3 and x equals 1 over 5. These are our two answers. We're going to write them over on the line. Everything making sense so far? The real fun problems are on the next page. So flip it over and take a look at number 5. Number 5 tripped up a lot of people because, and it was designed to, I did this on purpose. I'm trying to challenge you guys. Looking at this, you might immediately predict that this is going to be standard form because it looks like standard form on the left. We have a bx in the middle. This definitely looks like standard form, but we don't do that step yet. First, we have to get 0 on one side. So before we even decide what the form is, we are going to undo the 9x by subtracting 9x from both sides. And we're going to undo the 5 by subtracting 5 from both sides. So we rewrite our equation as 5x squared minus 35. Notice these 9x's canceled on both sides. Take another look at this now that we have 0 on the right. Is this standard form? This is vertex form. So we're going to write vertex form on the line. And we can solve this using, Cole?
Inverse operation.
You got it. You're my inverse operations guy now, all because you had an itch on your head. It's funny how life works out, right? All right. So we're going to use inverse operations. That means PEMDAS backward. AS, MD, E, P. First, we undo addition or subtraction. So let's add 35 to both sides. We will now have 5x squared equals 35. That was step 1. Now step 2 is undo multiplication and division. So we undo the 5. We divide both sides by 5. Oh wait, let me rewrite this. This is x squared equals 7. Next step on PEMDAS reversed is we undo the exponent. So we have to cancel out that square by doing its inverse operation, which is the square root. So take the square root of both sides. And what's that weird thing that happens when you square root both sides? Plus or minus. Very good. So hopefully that's becoming more natural now. You're just building it in as a habit. Every time you take the square root, you get the plus or minus. So we end up with x equals plus or minus square root of 7. Does the square root of 7 simplify? No, 7 doesn't have a perfect square root. So we're not going to change this. We're just going to leave it like it is. And our two answers are x equals the square root of 7 and x equals the negative square root of 7. Those are our two different roots. Is this starting to feel a little more natural? Good. Let's look at example 6. Standard form or vertex form? Vertex form. If we can, we always want to classify something as vertex form. It's usually a little easier. Now, since this doesn't have a bx term in the middle, we are good to go. We're going to make this vertex form. We are going to use the inverse operations method. And I'm going to go kind of quick on this one because we've gotten lots of practice at this today. Subtract 10 from both sides, leaving us with negative x squared equals negative 10. The next step is multiplication or division, and it doesn't appear that there's multiplication or division here, but there actually is. There's a bit of a trick to this. Colin, what are you thinking?
I said because it's a negative part.
that negative in front of the x squared is technically a -1. It's like there's a -1 in front of it. So we are going to divide both sides by -1. This is one way to do it. There are other ways to conceptualize this problem. So if you did this in a slightly different way, you're fine. We get x squared equals +10. Now we need to undo the square, so we're going to take the square root of both sides. And when we do that, we get the plus and the minus. So our answer should be x equals plus or minus the square root of 10. So we'll have two different answers, the positive version and the negative version. And 10, unfortunately, does not have a square root, so we can't simplify it. We'll just leave it like this. Moving on. Number 7 and 8, I want to do them kind of together. Look how similar these are. 3x squared minus 27, 3x squared minus 27x. The only difference is one of them has a 27 and the other one has a 27x. They look very, very similar. We have to treat these completely differently. What does example 7 have the form of, Colin? It is. What? I was going to ask, what is example 8? That's exactly right. So example 7 is in vertex form, but example 8 is in standard form because of the 27x. That bx makes it necessarily standard form. So our two solving methods are going to be different. In example 7, we can solve using inverse operations, but example 8, we have to solve using factoring. So let's do 7 first because it's a little easier. In example 7, we start by adding 27 to both sides. So we'll have 3x squared equals 27. Then we divide both sides by 3, giving us x squared equals 9. And last, we square root both sides, which is going to give us that plus or minus feature in our answer. So we get x equals plus or minus the square root of 9. Can this be simplified? Yeah. What's the square root of 9? Okay, so this whole part right here just becomes 3. So we get x equals plus or minus 3. So our two answers are positive 3 and negative 3. Easy enough. The next example is a little more challenging, and I noticed quite a few students get stuck on this. I get it. I wrote this problem to be particularly challenging. I wanted it to be tough. So I'm glad you guys persevered and tried to work through example 8. Thank you for a solid effort. And some of you, many of you actually figured it out. I was impressed. So in this example, it's a standard form quadratic. We must factor. If it's standard form and we must factor, then we want to make sure that it's actually written in proper, complete standard form. So that would be 3x squared minus 27x plus 0. We need that 0 at the end because we have to have an ax squared plus bx plus c. That helps us figure out where to put things in our grid when we factor. We will have a 3x squared in the top left, but we will have a 0 in the bottom right. That's why it's important to actually list the 0 there. Okay, that means we need two things that multiply together to give us 3x squared. 3x times x. We also need two things that multiply together to give us a 0. We have unlimited options. Anything multiplied to 0 will give us 0. So it could be 1 times 0, 2 times 0, 3 times 0, ... up forever. So we need to, one of our numbers will automatically be 0. So let's just say it's this one. That would give us a 0x right here. What number would I put in this blank so that I end up with a negative 27x? Just negative 27. So I put a negative 27 right here. So I get a negative 27x in this spot. So we can factor this into 3x minus 27 times x plus 0. Weirdly enough. And once it's in factored form, you know that one of your factors has to be 0. So you split this up into two separate equations and solve them both for x. You end up with x equals positive 9 and x equals 0. There are multiple ways to do this. So if you did this slightly differently, like if you factored out the 3 at the very beginning, or if you divided both sides by 3 at the very beginning, that is perfectly appropriate. I just sort of did it the brute force method, but there are multiple ways to do this. If you ended up with the correct answers, don't change a thing. Keep doing what you're doing. So our two answers are 9 and 0. We are out of time, so we are not going to get to the last example, but real quick, here's what you should end up with. X equals negative 3 plus or minus the square root of 11 halves.